audio system of Physis-based organs is highly versatile, offering control over both internal and external routing of voices, loudspeaker equalization, volume and spatial positioning. In this tutorial, I'm going to concentrate on the basic audio setup of organs with internal loudspeakers. As you can see here, depending on the model of organ, there can be up to 13 internal loudspeakers, arranged as 1, 2 or 3 stereo pairs of mid and high frequency drive units, plus a single bass channel that handles the entire organ. You can choose how notes of each voice are distributed to the left and right channels, and this determines the spatial effect. With internal loudspeakers, you have control over the left-right distribution of a voice, but the system deals with the channel routing automatically. In general, the more independent loudspeaker channels you have, the more authentic will be the sound quality. Among the reasons for this are that each channel has to reproduce fewer voices, and that fewer sounds have to interact within the loudspeaker channel itself. Simulated ranks can therefore mix more naturally in the air. The ensemble builds up more convincingly as more stops are combined if multiple independent loudspeakers are used. The internal audio system's tonal balance can be adjusted using the 5-band equalizer that's accessed from the Setup menu. You can scroll down here to the internal amplifier equalizer, and here you'll see that there are 5 sliders, each controlling the level of frequencies ranging from 100 Hz up to 10 kHz. That is from the bass to the treble. And there's a range of 8 decibels either way on these sliders. So if you want the high frequency end of the organ to sound brighter, for example, then you'd increase the sliders at 10 kHz and possibly 3.2 kHz a bit. The middle frequency sliders, such as 320 and 1 kHz, will affect the hardness and honkiness of the organ tone. Think of vowel sounds like or and r. And then the low frequencies, like 100 Hz, will affect the warmth and the roundness of the sound. Pipe organ ranks can be arranged in all sorts of physical layouts. For example, the tall bass pipes can be in the middle, with the short high-pitched ones at the outsides, or the bass pipes can be on the left, with a gradual decrease in size to the right, and so forth. The audio system on Physis organs allows you to simulate this spatial distribution of notes by panning them to different locations in the stereo image. There are also some alternative modes that route notes to specific loudspeakers. If I go to Internal Amplifier Panning in the Setup menu and select one of the manual divisions on the organ, in this case the grate, you'll see a list of the stops available on that division. And as with similar functions, you can either scroll down the list to select the one to adjust, or hold down a stop tab until its light flashes. So we'll select the first open diapason, and you can see that it's currently showing poly. This alternating polyphonic mode uses a clever algorithm that distributes the notes among the available channels in such a way as to avoid too many unison tones being routed to the same loudspeaker. It makes for a more natural summation of the combined sound in the air. Going down the list, the next option is mono, which means that the voice is routed to both left and right channels of a pair, with the result that it appears to come out in the middle of the stereo image. Right and left, on the other hand, mean that all the sound for this stop will come out from one or other sides of the image. The C/C sharp modes have a sound alternating between left and right every semitone, either in one direction or the other. And as we move further down the list, we get to the various simulated soundboards, shown here as little graphics that represent the arrangement of the pipes. The first one is a single wing, where the notes are panned so that the high pitches come out on the left and the low pitches on the right, or vice versa for the next mode. Then there are various alternatives, such as the double wing, where the high notes are in the middle and the low notes alternate towards the outsides, and the double and single cusps that put the low notes in the middle with either one or two peaks. Each stop can have a different layout if you wish, which gives the organ some authentic spatial interest and diversity. If we select the volumes page from the main control panel, it's possible to adjust the levels of different parts and outputs of the organ. So the first one is the master output control, the second one is the level of the reverb, the third one is the level of the headphone output, and the fourth one is the level of the external output. We need to press volumes quite regularly, otherwise it reverts back to the main screen. We've got controls then for the individual levels of the divisions, pedal, grate, swell, and the orchestral voices. So we could, for example, make the swell a bit louder and the grate a bit quieter. And the labelling may depend on your region and the configuration of the organ, and there may be some more divisions off to the right if it's a big instrument. I've shown you some examples of how to use the main audio system controls on a typical Physis-based organ with internal loudspeakers. There's considerable further flexibility to be had if external loudspeakers are used. And there's the reverberation system to discuss, both of which will be covered in separate Physis Explained tutorials.